In the last video, we looked at evaluating piecewise functions. In this video, we're going to continue and look at how you graph piecewise functions. Evaluating piecewise functions by hand would allow you to actually graph a function if you were required to do it by hand. However, since we have Desmos, we're going to actually use Desmos as a kind of a cheat tool, if you'll call it that. So remember, in piecewise functions, you have a big function. In this case, it's f of x. Then you have two smaller functions. I'm going to call it, again, a of x and b of x. The way you want to start out graphing piecewise functions is to write the function a of x in Desmos. So a of x equals -2 x minus 1. Okay, and then you put in your domain restriction. So x is less than or equal to 2. So what you want is where your restriction, in this case, x less than or equal to 2, and your red line function, which is a of x in this case, intersect. So if I look, I can see they intersect at this point right here, so 2, -5. So I'm going to plot that on my note screen. Again, the scale is going by 2s, so +2, -2, -4, -6. So right here, to -5. And be careful when you do this. So I did it without even thinking, but because this 2 is shaded, or I have a less than or equal to sign, or a greater than or equal to sign, whichever one pops up, that's going to allow me to have a shaded dot on this line. Then I need to pick out some other points. So I'll go back up to my red function, and I have 0, -1. Then I have -0.50. So this was -1, split the difference. Then I'm just going to draw it. Now, piecewise functions are pretty cool in the fact that they don't go on forever and ever. So if I look at this red line, or this red function, I can see it continues to go on to the right. However, where the graphs intersect each other, that's going to be the end of it. And at the end, you're either going to have closed dots or open dots depending on your inequalities. Okay. So after I graphed a red one, I'll then graph b of x. So I have this green line, but now, so once I do that, I'm going to hide my other 2. And I'm going to say x is greater than 2. Now, greater than gives me a dashed line, and I have the point 2, 2. But because I have this dashed line, that lets me know it's going to be open. And again, I want to get a couple of points for reference. The way you can get it to pop up is just, again, put your cursor and click where you type the function at. So I get 4, 0. Another one looks like it would be 9, -5. Whoops. So I actually did this entire thing, which is okay. But if you see in my notes, I actually separated them into two different parts. And the reason I do this is because I would recommend graphing one function at a time and then put them both together. And just for simplicity's sake, I'm going to color this one blue, and I'll color this one green. So then when I actually plot them together, I can go 0, -1, 2, -5, then -0.50. Again, I knew this was a of x. This point right here is very important. Then my green function was b of x, which occurred at 2, 2. 4, 0. 5, -9. Or, excuse me, 9, -5. Again, you just want to get this as close as you can. Getting it perfect isn't 100% important, but that's how you graph piecewise functions. Start off by plotting each piece individually, label it so you know which one you're looking at, then put them all together. Something that I like to do, again, because we have multiple choice questions, is to label a of x, plot the first one, plot the second one, plot the third one, whichever one you think is going to be easier, less typing in Desmos, and then go look at your answer choices A, B, C, D, and match and like, oh, this graph right here, you know, has a closed dot versus an open dot, whereas on the answer choice it's got open dot, so it can't be that one. So something that important is going to be what gets you the correct answer versus the incorrect answer often enough. Again, just your greater than sign is going to be a dashed line, and it's also going to have an open dot. Your inequalities will equal to will be solid lines when we do the restrictions, and you'll have closed dots. So on page 26, you can look and see we go into more complicated functions. Because of that, again, start off by labeling, and I'm actually going to use different colors here. I'm going to say whatever is orange is going to be a of x, and then b of x will be that color. So I go back to Desmos, clear out everything I had originally, then I type in a of x, is equal to -6. Underneath that piece, I'm going to type in my domain restriction. And then I want where it intersects. So the point -2, -6, -2, -246. I always recommend starting with an open dot and then going to my inequality and then verifying. So it's a less than sign. So I'm going to look to the left of where these intersect, again, where the shaded part of the inequality and your function meet. Then I just want that so it's a horizontal line. And again, this point was -2, -6. So that's A of X. Now I need B of X. So I close these off. And I'll type in my new piece. If you don't give your function a name right here, it's possible to run into trouble, so be cautious of that. X plus 1 raised to the 4th power. My domain restriction, X greater than or equal to -2. Again, find the point where these intersect at. So that's -2, 1. Again, -2, 1. And it's closed because of it being a solid line and my greater than or equal to, less than or equal to symbol. Another point for reference would be -1, 0. And after you plot that first point, everything from then on is closed. So this again is how you plot and graph piecewise functions. And just for good measure, again, I always like to go back and label my functions.